All right, so we're on number 17, and it says, consider the substitution reaction below. So, all right, they're telling us it's a substitution reaction. So here's our molecule. It's R3 iodo 3 methyl heptane, right? And it's R with the I going away from us. The more okay, right, the I is going away from us. The iodine is on this stereogenic center. The iodine is the highest group according to the Kohn-Ingold-Prelog system, I think is what it's called. So if it was coming out at us, the quickest way to get to the most carbons, which are on this side, this over here, would be to go counterclockwise, which is S. But since it's pointing away from us, it goes like this. It goes in the opposite direction. Then it looks, and it's R, right? And we're treating it with sodium acetate. So we have the acetate anion, which is the base version of the acid, of carboxylic acid. It's the conjugate base of carboxylic acid. So, okay, what will happen? That's what they want to know. All right, are we going to get SN1 with retention of configuration? Are we going to get the stereogenic with retention of configuration at the stereogenic center? Are we going to get an SN1 reaction, which would take place with Rasmusation of configuration at the stereogenic center? Would we get SN1 reaction plus E1 reaction? 4, would we get E2 reaction with loss of stereogenic center? Or would we get SN2 with inversion at stereogenic center? All right, so this problem was kind of weird, and I didn't get the same answer that was given. So up here they said it's substitution, right? This is what are we dealing with here? We have a 3rd degree substrate. The the iodine molecule is connected to a third degree carbon. It's connected to 1, 2, 3 other carbons. So that means we're going to get no SN2 reaction, right? We have an aprotic solvent. Right, an aprotic solvent. Oh. Aprotic solvent. It's an aprotic solvent. But could it... Alright, I guess this is... Well, I'll talk about this. It's an aprotic solvent, which you would think is no SN1 or E1 reaction. It has a good nucleophile, the acetate ion. It's a weak base, aprotic solvent, and third degree substrate. So that would make me think it's an E2 reaction, right? So I've chose E2 reaction with loss of stereogenic center. They said SN1 reaction plus E1 reaction, and maybe, all right, I'll write them both out. This is the answer that they gave, right? The one with the star. And this was my answer, but maybe I was wrong. So if we look at, maybe this acetate is too weak. Give me 1 second. I just want to look at the acid-base table in the book. How to predict acid-base reaction. Okay, here they have stronger acid. All right, acetic acid is a strong acid, right? I didn't go past the thing yet. Acetic acid is a strong acid. CH3. Yeah, okay. It's a relatively strong acid, but so it's it's medium strong acid, so it's a medium strong base. So okay, it's a medium strong base. Let's see. Maybe it's too weak to do an E2 reaction. So this is what I said, but now I'm trying to think. The way that they're saying it doesn't really make sense to me either. So here's the molecule. And the way I was thinking was that this aprotic base here would, sorry if I'm like being slow and stupid. It's a third degree, only E2 possible. All right, so anyway, this is where I thought it would be E2, right? So the sodium, the acetate anion would take this hydrogen, which would then give its electrons to this bond, break off the iodine anion, and we would get this molecule plus acetic acid plus sodium cation. Right, so, but they're saying SN1 plus SN plus E1. So in order for that to happen, the acetate ion would have to become somehow, it would have to become protic, right? It would have to become protic, and in order, it would have to pluck off a hydrogen from somewhere without creating an E2 elimination. But this is the best hydrogen for it to pluck off. Yeah, I think they're wrong. I don't think this makes sense. So actually, I'm going to post this one in the forum.